What scientists just uncovered beneath America's heartland is nothing short of earth-shattering, literally. From ancient oceans that nearly split the continent to parts of the Midwest sinking into the mantle, these new discoveries are rewriting everything we thought we knew. As climate chaos, hidden fossils and vanishing oxygen zones collide, the calm farmlands may be standing on the edge of a geologic awakening. Thoughtful, could the Midwest be the most dangerously underestimated region on Earth?
America is sinking. It's due to a geological change. The entire North American continent is dripping under the Midwest US.
Beneath the Heartland, secrets of the Midwest, unveiled. In the hushed dawn, over expanses of waving grass, jagged bluffs, and meandering rivers, the Midwest appears peaceful. Steadfast fields, anchoring entire towns, shallow lakes holding the sky in a mirror's stillness. This heartland, stretching across the central body of North America, is often painted as an agricultural engine, a place of gentle hills and familiar seasons, a cradle of wheat and rivers, not cataclysm or upheaval. But layer by layer, beneath its surface, scientists have unearthed extraordinary mysteries that challenge every settled assumption about this land. What if, far below the quilts of prairie and corn, the very bones of the Midwest tell of continents torn open, of fire, water, and monumental change? What stories slumber behind the scars of vanished seas and rivers, or pulse within clouds that gather rain and refract ancient secrets? In recent years, new discoveries have turned this purportedly mundane region into a theater of geologic drama and hidden turmoil. From the invisible scars beneath Michigan hinting at almost oceans, to curious drippings of crust into the planet's deep heart, and rainfall patterns shifting under the weight of human influence, the Midwest holds riddles beneath its gentle skin, riddles as vast, dynamic, and unsettling as any on the planet. Why has the attention of the world's leading researchers suddenly focused on the seemingly unremarkable terrain of the central United States? What have teams from Texas to Michigan glimpsed in the underworld of rocks, waters, and mantle? And how could the truths revealed in this region force us all to redefine what we know about Earth's past and perhaps its future? Join us as we journey into the astonishing revelations lying beneath the Midwest, stories that shake the foundations, both literal and figurative, of all we believed about North America's heart. What exactly lies beneath the ground, waiting to reshape history once more? The rift that almost was. Michigan's ancient scar. Vast and placid to the eye, the Great Lakes region of Michigan appears anchored in an age-old calm. But time's deep ripples have left their mark in ways nearly impossible to imagine at the surface. In the distant past, as the Earth's crust stretched thin and stressed under shifting tectonic forces, a remarkable event began. A drama of fire and water poised to remake a continent. Scientists, tracking the echoes of ancient convulsions, discovered what they now call a scar, the faint but persistent signature of an ancient rifting event. Here, magma once bubbled up from below, threatening to split the crust and create a new sea. This activity emerged below what is now Michigan, where the planet's crust, pulled and riven by geological forces, came close to sundering. Had the process continued, an ocean might today divide North America. Coasts and islands would reshape its geography. But for reasons scientists are still working to understand, perhaps shifts in forces deep within the Earth, or changes in tectonic stress, the rifting stopped and the wound was sealed before a true ocean could flood the breach. Yet the traces of this event remain. Geologists studying ancient rocks, seismic data, and mineral deposits have pieced together this hidden story. The imprint of ancient magma flows remains in the form of basaltic intrusions and deep fractures beneath Michigan. Blobs of solidified rock, weathered and silent, stand as evidence of once searing heat and near revolution. This scar is both a record of what did happen and a window into what might have been. These marks are still being studied. Along the rift, minerals such as copper and nickel, along with rare earth elements, are clustered, remnants of volcanic activity that now attract both scientific and economic interest. Mineralized zones here offer insight into Earth's evolutionary chemistry. The rift also shapes groundwater movement. Ancient aquifers may rest atop solidified lava, influencing today's water resources and how ancient volcanic activity still affects daily life. The ancient scars even help define today's landscape. In recent years, minor earthquakes occurring in the region remind us that ancient structures persist in influencing seismic activity, even if only gently. As researchers continue to probe Michigan's crust, every scan and core sample draws us closer to understanding how near the continent came to being split by fire and unrest. These discoveries provide context to the stability we now take for granted and remind us how quickly nature's script can shift. Drippings in the deep, the sinking crust of the Midwest. Beneath the stoic towns and fertile fields of the central United States, the Earth's engine continues its mysterious workings. For centuries, the Midwest's geology was believed stable, a reliable platform. But recent scientific investigations have upended this certainty, revealing a hidden process. Parts of the continent's underside are dripping into the Earth's mantle, a phenomenon both extraordinary and largely invisible from the surface. How did scientists uncover this slow descent? Using advanced seismic surveys, essentially listening for vibrations as energy passes through the ground, researchers identified anomalies beneath the Midwest. Instead of simply sitting atop solid ancient stone, portions of the crust appear to be breaking off in immense, downward dripping masses. These sinking blobs of rock, gradually dissolving into the upper mantle below, shape a process now known as cratonic thinning. Researchers, including teams from the University of Texas at Austin, have documented this geological transition. The lower boundary of North America's craton, the ancient, stable core of the continent, was long thought to be unyielding, but rising heat, changes in mineral composition, or subtle changes in pressure have weakened it in places, allowing portions to drip away. These drips, slowly melting and sinking, can alter the structure and chemistry of the crust above. These findings are underpinned by advanced computer simulations and deep earth imaging. Sometimes, layers of softer minerals at the base allow for greater movement. Elsewhere, upwellings of heat help to melt the deepest rock. The process is astonishing, not only in its nature, but in its timescale, spanning millions of years, continuously remolding the land beneath our feet. What might this mean for life above? While these changes unfold too slowly for humans to feel directly, the gradual loss of crust could subtly change the Midwest's surface over eons, through subsidence, the creation of new faults, or by slowly altering local geology. Some researchers even consider whether such deep processes might someday influence volcanic activity or help drive the cycles of mineral replenishment. But as of now, there is no evidence of imminent volcanic threat in the Midwest. Instead, the lesson is one of unexpected dynamism. Crust presumed solid and stable is, on geological timescales, shifting and alive. What other revelations lie hidden, waiting for more precise instruments to reveal them? The slow drip of rock into the mantle is a reminder. Beneath even the calmest fields and forests, the Earth's story is one of ceaseless change. Rainfall of uncertainty, the Midwest's shifting climate. Once, rainfall in the central Mississippi Valley was merely part of a cycle, life-giving, expected, the pulse of spring and summer. But today, Clouds over the region carry different messages. Scientists documenting regional weather patterns now observe that rain events are becoming more extreme, sudden, and, at times, devastating. Worryingly, studies identify a human fingerprint. Climate change has made some severe rainfall events significantly more likely. A notable example: a recent study found that one intense 4-day rainfall across the central Mississippi Valley was made at least 40% more likely by human-caused warming. This is not speculation. It is supported by direct models and rainfall data showing the impact of increased greenhouse gases on driving heavier, more frequent precipitation. What does this mean for those living across the Midwest? Farmland and communities once able to manage typical storms now face flash floods, lingering inundations, and more frequent disasters. Riverbanks breach repeatedly, while agricultural schedules are upended. Crops fail not just from drought, but from excessive water, and infrastructure, from roads to bridges, is tested by surges unanticipated a generation ago. The resulting economic consequences ripple across the region. Farmers face ruined harvests and replantings. Small towns spend limited budgets on disaster response and resilience. Insurance companies recalculate risk as historical norms are replaced by new extremes. Ecosystems, too, suffer. Wetlands and prairies cherished for their diversity are hit by repeated shocks, and recovery becomes harder. Disturbances affect everything from pollinators to bird migration, while invasive species can capitalize on stressed habitats. If just one significant event is now 40% more likely, what will future decades bring? How do people adapt? Farmers, city planners, entire states, when the very odds of nature seem rewired. Researchers and policymakers find that each new season brings more data, more questions, and a growing urgency. The Midwest, shaped for millennia by water and wind, is now at the forefront of a changing climate, a climate where the next storm may break another record. Rain, once a routine part of life here, now carries a warning. Can adaptation keep up with change, or do these new patterns demand a far deeper reckoning about how to live on this land? The invisible crisis, hypoxic zones, and the fate of the water. From the high plains to river valleys, waters journey southward through the Midwest, carrying more than just sediment and nutrient. These waters eventually flow into the Gulf of Mexico, where an ecological crisis unfolds largely beyond everyday sight. The spread of hypoxic zone, regions so depleted of oxygen that most marine life cannot survive. This phenomenon, commonly called the dead zone, represents the end point of a chain reaction. Nutrients, especially nitrogen and phosphorus from agricultural fertilizers, are washed off fields by rain and funneled via streams and rivers into the Mississippi and eventually the Gulf. There, these nutrients fuel massive blooms of algae, which die off and are decomposed by bacteria, a process that strips dissolved oxygen from the water. The consequences downstream are immediate and severe. Oxygen-deprived waters, decimating fisheries, and threatening local economies on the Gulf Coast. Shrimpers and fishermen encounter drastically reduced catches. Scientists meticulously track the area of these hypoxic zones each year, finding it fluctuating in response to rainfall, farming practices, and changing climate. In wet years, the zone typically grows. During droughts, it might shrink. But overall, the trend remains worrying. Crucially, this is not simply a Gulf crisis. It is inextricably tied to choices made thousands of miles upriver. The size of the hypoxic zone can reflect conditions in Iowa or Illinois, enacted by the rainfall that carries fertilizer out of fields and onward. The interconnectedness between fertilizer use in the Midwest and the fate of the Gulf's fisheries is now a matter of documented science. What can be done? Scientists and policymakers propose strategies ranging from cover crops and buffer strips, which can reduce runoff, to advanced treatment systems and more judicious fertilizer use. Some local projects have seen success, demonstrating that careful stewardship can curb the flow of nutrients. But the scale remains daunting. To truly address the problem, changes would need to be adopted widely across the entire Mississippi watershed. Will these efforts suffice? Or is the dead zone an inevitable byproduct of our approach to agriculture? The future of both Midwestern farms and Gulf fisheries may depend on the answer. The warming hole, Anomaly, or Omen. Amid these trends of increasing heat and intensity, a climatic curiosity persists. Despite overall global warming, a swath of the Midwest demonstrates a so-called warming hole, an area where temperatures have not risen as quickly as in surrounding regions. This anomaly has puzzled scientists for years. Researchers confirm the existence of the warming hole by analyzing weather station data, satellite records, and climate models. Here, in contrast to global averages, some areas have experienced milder temperature increases or even localized cooling for decades. The cause is still under investigation, but leading explanations involve shifts in atmospheric circulation patterns, increased rainfall, and resultant cloud cover, or possibly even land use changes associated with agriculture. Some research suggests that the humidity and evaporation from crops, especially irrigated cornfields, can locally cool the air and increase cloudiness. However, the effect may be temporary. Many scientists project that, in the coming decades, the global warming signal will intensify across the Midwest. Is the warming hole a temporary reprieve, or does it mask deeper vulnerabilities, like increased risk of heavy rainfall or drought once the trend reverses? Experts are cautious. The absence of strong warming here is not a guarantee of future stability. Instead, it's a reminder of how global patterns can produce very localized anomalies, sometimes protecting, sometimes endangering those within. What lessons should planners, farmers, and citizens take from this? For now, scientists recommend vigilance and flexibility, being alert to rapid changes as the story of the warming hole continues to unfold. The unseen tides, rivers of stone and memory. Long before modern settlement, the Midwest was molded by forces now hidden, a landscape shaped by the advance and retreat of ancient seas, massive glaciers, and shifting rivers. Beneath layers of soil and city lies a fossilized archive of these past worlds. Geologists use seismic imaging and boreholes to map extinct riverbeds paralleling today's Mississippi and its tributaries. Saltwater aquifers, now submerged, hint at a time when much of the Midwest lay under broad inland seas. The sediments beneath our feet contain fossils from grasslands, forests, and ancient waterways. In some areas, core samples reveal remnants of ancient deltas and river systems, now petrified and hundreds of feet below the surface. These stories are interwoven with the glacial episodes that scraped land clear and created the present-day Great Lakes. Even the fossilized remains of prehistoric animals, giant turtles, mastodons, extinct horses, lie buried alongside river-rounded stones and preserved pollen, evidence of shifting climates and ecosystems. Each layer in the ground serves as a chapter in a long, complex story of water, ice, and land reshaping one another in cycles stretching over hundreds of millions of years. This geological memory isn't just abstract history. Ancient aquifers still fuel agriculture and provide city water. Ancient floodplains can point the way to future river migration. Retreating glaciers left behind rich soils and rolling hills that support today's farms. The living laboratory, science, uncertainty, and the future beneath our feet. In labs and field sites from Texas to Michigan, scientists probe, sample, and record the shifting reality beneath the Heartland. Their work has upended old understandings, transforming the Midwest from a static expanse to a landscape of surprise and dynamism. Across the region, evidence accumulates that yesterday's certainties are today's puzzles. The scar beneath Michigan invites us to reconsider geologic risk and the memory of almost oceans. The Midwest now serves as a living laboratory, its mysteries driving advances that ripple to fields as distant as climate science, hydrology, and even global food security. The ring of uncertainty around what will change, how quickly, and with what consequences, encourages a spirit of humility in interpreting and managing our environment. Even the familiar must be watched anew as storms grow stronger, rivers more unpredictable, and deep layer transformations continue beyond our sight. Perhaps the greatest lesson is this: beneath the heart of North America, the land is alive, a record of memory, accident, and possibility. The earth beneath, far from silent, is in constant motion. Scars mark old dramas, layers conceal vanished worlds, and every year adds new pages to the story. What teachings remain to be found in the next deep scan, or the next drought, or the next surprising rainfall? The Midwest, once dismissed as unchanging, now stands revealed as one of Earth's great chronicles, an epic of water, rock, climate, and the search for understanding. What have these discoveries awakened in you? Does knowing that magma nearly split the land, that portions of the crust sink quietly into the planet's depths, or that ancient seas lie sleeping under fields of corn, inspire awe or caution? The conversation between land, science, and people is just beginning. Share your thoughts, your own mysteries, or the questions that keep you curious. Stay inquisitive, challenge what seems settled, and journey again beneath the surface. The Heartland's secrets are far from finished. Each discovery only deepens our wonder and the unfolding story of what lies below.